Thank you for the opportunity to present our work, Feature Space Data Space, a theoretical framework for the dual analysis of feature space and data space. I am Frederik, and let's jump right into the topic of dual analysis. Dual analysis is a common method for data analysis, and it's used to jointly explore data items and features or dimensions. Here you can see 6 examples where you have this joint analysis of data items and features. For example, here in the top row at the very left, you have the approach by Turkey et al. And it has a data item view on the left and a feature view on the right. And you have these scatter plots that when you select a subset of features, for example, it modifies the scatter plot on the left so that you get another dimensionality reduction, which takes these selected dimensions or features into account. Or you have, for example, the approach by Mennatallah et al. Or Corporate et al. That do not follow this principle of using scatter plots, but still they are dual analysis approaches since they have these linked views, one focused on data items and the other one on features. So we can see that feature space and data space are directly linked. And you can see this here systematized, so to speak, that you have a feature space where you can do feature-based interactions, for example, reduce the dimensionality by selecting dimensions or applying dimensionality reduction methods, generating new features. And on the right-hand side, you have the data space where you can apply clustering algorithms, for example, to get groups of data items. And these interactions have a direct effect on the other visualization. For example, through feature selection, highlighting or determining features that are important and highlighting those and giving them more emphasis in the feature space visualization. So in our work, we have 3 key contributions. The first part is a systematic literature review where we describe fundamental properties, goals, and use cases for dual analysis. We have a theoretical model in our publication for dual analysis where we describe the key components, each with a formal description, finally with the goal of describing the design space of dual analysis. And in the end, we have also a validation of our framework where we describe existing approaches through our formal framework and really show that we can use our framework to systematize all existing approaches here. And we also have a section about generative use, meaning that our framework also really highlights important directions that research could go. So at first, I would like to start with a definition of dual analysis that we reached through our research. So in general, dual analysis facilitates the joint visual analysis of feature and data space through a view visualizing features, i.e. what we call the feature space, a view that shows data points, i.e. the data space, and lastly, a linkage, a mechanism that links both views in a bidirectional way such that the interaction with one visualization changes the other visualizations. So as we saw before, feature space and data space are directly linked. The area of dual analysis and form our framework, we performed a literature review covering 197 publications. In the beginning, we started with 4 landmark papers, we call them. In the next step, we wanted to check if there's more out there, and we followed basically the citations of these publications forward and backward, which allowed us to get an idea of what dual analysis could be in a formal and model-like sense. Then we had 15 of those publications, but we wanted to make sure that we really cover all approaches that are out there following this paradigm. And just to make sure that we got everything, we performed a keyword-based filtering where we went and looked in an automatic way through our publication database, where we got then 197 publications. In the next step, we went through these papers, rejecting them, refining them, formed also our model, where we in the end had 34 papers. In this very last step, the sample validation step, we went through all of those 34 papers, and we indeed had to reject again 11 papers just because this linkage mechanism was just one way, and we saw in our previous definition that we require through our definition to have a bidirectional mechanism there. In the end, we have 23 dual analysis approaches, and here you can see the basic systematization of those that you can find in the paper. We have information about the visualizations used, the transformations used for feature and data space. We also have scenarios, which I'm going to talk later about. These are basic guiding scenarios addressing dual analysis, and we also talk a little bit about the domains. In terms of interactions, we found 3 main interaction methods. One is selection, where you have either a rectangle or lasso select of some kind, mostly on the points of scatter plots, that then in turn trigger the update of the accompanying visualization. Usually this is also very symmetric, that you have 2 scatter plots that act very similarly. Another method we found is dragging and dropping of points. So for example, dragging a feature in the feature space visualization gives emphasis to this feature or de-emphasizes it, and similarly also symmetrically for the data visualization. Finally, we also have focus and context mechanisms, where you have zoom-in methods or highlighting methods that give you highlights in the accompanying visualization, allowing you to focus in on certain findings in certain groups. So finally, here is the formal framework that we developed. We have here a couple of functions here that we describe in detail in the paper. I'm not going to cover this here in this presentation. Very shortly, we have in the colored boxes our guiding scenarios, where we cover feature selection, feature aggregation and weighting, statistical analysis, similarity search, subspace cluster analysis, data aggregation and weighting, and data selection. And you can see that we have basically the symmetric pipeline on both sides of the data item visualization and the data space visualization, going from left to right, having an initial selection step, having an aggregation step, and a visualization step in the end, where you have also the aforementioned interactions. Finally, to conclude, we have a formal framework here that is based on a literature review covering 197 publications. We describe 7 guiding scenarios where dual analysis is a solution, and also embed them in our formal framework. Finally, we have a formal unified framework that describes dual analysis theoretically, and also we have 5 opportunities that can be addressed in future research and are, in my opinion, definitely worthwhile to be explored. All right, that concludes my presentation, and I'm happy to take questions if possible. Thank you very much for your attention.